Using limit to find the tangent, so kind of back to that very first thing we talked about. We talked about the change in y over the change in x. The limit of that can give us the slope of the tangent. Okay, and so we're going to learn two techniques in doing that. One of them is this guy here. So this is the guy you'll want to write down. So the limit, remember that triangle means change. Okay, limit of change of x to 0 is change in y over change in x. Or limit as x goes to a for f of x minus f of a over x minus a. So you plug in your limit into the function, and you keep the function as is. F of x means you leave it in x form. Okay? So these stay x. A is where you actually put values in, so it'll be a number. Okay? You'll see what I'm talking about when we do the example. This is the easier way. And then we're going to have a second technique. It's a little bit harder. We're doing that one for a purpose. So if you're saying, why don't we always use the easy one? Because the harder one's going to come into play later. Okay, so the definition of tangent amounts to saying that the tangent line is the limiting position of the sequence lines. So again, kind of go back to the conversation with Booker, is like, why are we talking about ones that go through the parabola? This is why. Because as this approaches, it's going to approach the slope we want. So the limit is approaching that slope. So just like we talk about limits, our limits approach a number. In this case, it's going to approach that tangent slope as we keep looking at it. Okay? So that's what they do with it in terms of finding the tangent. Okay, so I know it was confusing last time we were talking about, well, why did we go through the parabola? Well, we actually went through the parabola as like almost like a reference point. So this is a reference point, that's a reference point, and we're adjusting it until we get really close to the actual slope we want. Close is what we're looking for. Okay? Any questions before we hammer out the first example? Okay, so find the slope of the equation of the tangent line to the curve y equals 2x squared plus 4x minus 1 at the point 215. So when we find the slope, we get the point to find the, like we have to use the stuff we did in our review to figure out the equation of the line. We use the limit to find the slope, but if we just have the slope, do we have the whole equation? What are we missing? B. We have to find the y-intercept, exactly. So we use what I just showed you to find m. Okay, that's what the red box said. That was m. M. That's the slope. Okay. We use that to find the slope, and then we'll plug the point in to find b. Okay, so here's how we'll do it. So we are going for, so we're finding m. So m equals limit as x approaches 2. Why do I get 2? Where's the 2 from? That's my x value. Okay? So limit as x approaches 2 of f of x minus f of 2 all over x minus 2. So look what happened when I set that up. I can't just plug in 2, right? Because I plug in 2, I get 0 on the bottom. Okay, so that's why we're going to use this to kind of our advantage to help here. So f of x is this. So I write that, 2x squared plus 4x minus 1. And then I have f of 2. So I plug a 2 in here, what do I get? So you have to do that really quickly. So 2 squared is 4 times 2 is 8. So I get an 8 plus an 8 minus a 1. So I get 15. Everybody see that? Okay. So I put plus 15. It's minus. It's minus f of 2. So minus 15. Okay, and my bottom stays the same. So we're hoping what's going to happen? And so we're hoping that the top we can do what? Yeah, we're hoping we can factor the top. So first off, first step of factoring is to what? Greatest common factor. They all have a 2 in common. Okay, I'm just going to write this. We're going to factor that now. So it's going to be 2 times x plus 4, x minus 2, all over x minus 2. Now we're happy. because the x minus 2 cancels. And now we can evaluate that limit. Our answer is 12. 12 is the tangent slope through that point. Are we okay? So then quickly to figure out b, we're going to go 15 equals 12 times 2 plus b. 12 times 2 is 24. Minus that to 15, b is negative 9. So our equation will be 12x minus 9 is the equation of the line going tangent through that point. Okay, we'll do a quick we'll do a quick Math 20 review for completing the square, because it's helpful for graphing. So to graph this, as part B says, we have 2x squared plus 4x minus the 1. I'm gonna complete the square because I'm gonna draw what this parabola looks like. Obviously, you can put this in your calculator, but you need to know how to sketch this. So I'm gonna go 2x squared plus 4x plus box minus the 1. Half of 4 is 2. 2 squared goes here. Oh, sorry. Dang it. Have to pull a 2 out first. There we go. Half of 2 is 1. 1 squared is 1. We're completing the square to get in vertex form, because vertex form is easier to graph. Okay. 2 times 1 minus 2. So this is helpful because it's easier to graph is why I'm doing this. That is what we have here in vertex form. So I have my vertex. My vertex is at -1, -3. Okay. And we can still use this as my y-intercept. Okay. And we know it's going up. So be like right about there. So it's going to be roughly like this. Okay. And so the next thing we want to look at is the fact that we just made the 12x minus 9. 12x minus 9 is going to be, oh man, I don't know if I'm going to make it. 1, 2, 3, 4, 5, 6, 7, 8. Oh, I will. 9. If I do this and I go all the way up to here, it's essentially going to hit this right there. That's where the tangent point is. So this line will roughly, if I can get it here, it'll like hit it like that. Okay, obviously that's not at 9, but it's going to hit through there. Yeah, sorry, my scale's obviously off, that's why it's hard. But it starts at -9, going through 12, that's a spot it's essentially going to hit right on, and then it's going to go through there. And that's the 2, so it's actually even a little higher, but just in terms of the concept, that's the idea of what's happening there with the parabola and the line we just figured out. Okay, because that's actually going to hit 215. But okay, all right, so now the second method. Well, first off, was there questions on that method? Did we do anything confusing there? I think we kind of did that in lesson 1 a little bit already, so hopefully that wasn't too bad. This one will be a little bit more complicated, however. Okay, so another expression for the secant line PQ is f of a plus h minus f of a all over h. So we can use that. Limit is change of x goes to 0. Change of y over change of x can also be written as limit as h goes to 0 for f of a plus h minus f of a all over h. And this is method 2. So when you get to the textbook and it says, it'll tell you use method 2 or method 1. This is an illustration of that. Oh, sorry, I'll go back. Sorry, if you're writing that, I'll pause for a second here. Okay, so here's just an illustration of that. It's just showing the illustration of here's a f of a, and then if I go h, a plus h, so this distance h, this distance is the f of a plus h minus f of a plus h, f of a plus h. So it's just showing you kind of the different points. Again, the same idea. We're doing the limits cut up as it's approaching that tangent point. So this one, okay, find the tangent line to the hyperbola xy equals 1 at the point. So first off, what's alarming here? When you first look at this, what are you going to do? Or yeah, hyperbola, I don't know what the heck that is, number 1. Okay, good. We like y by itself, right? So that's the first thing you're going to do anyways. We're just going to, we're going to divide the x off. Y equals 1 over x. Now that's an f of x form. It's a function of x now. Before, you didn't have a function of x. Okay? Hopefully, from earlier, you know what 1 of x looks like. It's that one with the asymptotic zeros, and it's the two hyperbolas going away from each other in the corners. Okay? But it wants us to find it at the point -2, -1/2. However, what did the difference between this method versus the previous method? Well, we took the limit at the x-coordinate. This one we're doing it at what? 0. Okay, so that is important. So we are going to, here's a setup for method 2. Limit of h goes to 0. Okay, f of -2 plus h minus f of -2 all over h. So this is why we did function composition in your review, because we had to plug in -2 plus h into the function. Now this is an easier one. So when I plug this into x, it's just going to be on the bottom. Okay, so you're going to have this. The top is going to look like this. 1 over -2 plus h minus 1 over -2. So we can write that as plus 2, correct? Minus a minus. Okay. So what do we want to do here, though? I want to put those together. They're still all over h, but I need to get these together. Common denominator. And I can't just do the nice, cool plus h, don't do anything over here, because that's not going to work. Okay? You have to do common denominators with multiplication. So I have to do -2 plus h, -2 plus h. And I left a -2 in my notes. I'm not sure why, but I'm gonna go for 2 here. Hopefully this doesn't backfire. Okay. So we will distribute these. Okay, we'll distribute here. So we're going to get 2 over -4 plus 2h plus -2 plus h all over -4 plus the 2h again. So those are the same. So now we can combine the top. So what goes away? Yeah, the 2 does, right? Okay, so that's what it is combined. And remember, don't forget this whole thing's over h, which is helpful because where does that h go? It just goes right here, right? And so that means essentially it's going to cancel that one. So it's going to be this. Can I evaluate that now? Don't forget, where do we come from? This is where we're at. Sorry, if you're lost, ask a question. But let me write where we're at right now. We are right here. That's where we're at. Can I take the limit of that now? I can. If I plug a 0 in, what do I get? Negative 1/4, yeah. Okay, so, Emily, got a question? Did I lose you? Don't be brave. No. What do you got? What's the question?
It's like from the beginning.
Okay, well, let's start in the beginning then. Which part?
First off, I'm confused why you put in -2 put in A and then wait, never mind. Okay,
So this is, remember, it's f of a plus h minus f of a. That's the formula.
yeah.
So a is -2 plus h and then -2. All over.
From your x value.
Correct. We still use that x value for that. This is still our a, but we're using h approaches 0. Good question. Okay, that's a good question. You guys get that? So a is still going to be the point we're going towards. So the same a we had last time, we'll still use as our a here. We're just not we're not doing the limit at a anymore. It's the only difference. We're doing it at h. Yep.
So why do you plug the -2 for it? Like is A
Because -2 is my x.
and is A supposed to be x?
Right, f of x. F of a.
Okay.
Yeah. Because that's your input, right? Good? Great, that's what I wanted. Anything else? Okay, we worked through here, did all this fraction work. We finally got it to the h canceled, so we now have the h equals 0 on the bottom. And then we could plug 0 in, and our answer is -1/4. This is the slope of the tangent, okay, to figure out the actual equation now. So they didn't ask us to do. Oh, yeah, they did. So we would go y equals -1/4 x plus b. Let's actually just plug in y. Y is -1/2. So this is me solving for b. That's a -2, sorry. So -2 times -1/4 is going to be +1/2. So -1/2 equals -1/2. Nope. +1/2. I just said that. Sorry, you can't see that negative right there, but that 2 has a negative on it. Okay, -2 times -1/4 is +1/2. We'll minus the 1/2. -1/2 minus 1/2 is a -1. So our b is -1. So our equation is here. That's the equation of the tangent line to the point -2, -1/2. Questions on that? Okay, I'll pause the video for a second if you're finishing things. Okay, so this looks like this. We have that's a hyperbola. So this is what 1 over x looks like. -2, -1/2 is right here. That's the point we're trying to find tangent to. Remember, we just got -1/4 x minus 1. So to make it more to scale here, the last one wasn't to scale very good. It'd be like this, -1. That's what our line looks like that we just figured out. -1/4 x minus 1 going through that dot at one spot. Okay, that's what we just did. So that line, this is what we just found. This is your answer. Okay, we just got one more example. I know it feels like crazy, we've only done 2 examples, but we We have one more example. All right. Guys good? All right. Okay, so now we got a uglier one here. Got a nice radical one. Okay, it wants us to actually use the method we just used, so we're going to stay with that. So we are going to stay with the f of a plus h minus f of a all over h1. Okay, so to like kind of be a little thorough here, we're going to go f of, our a again is still the x, so f of 6 plus h minus f of 6 all over h, and remember that limit as h goes to 0. Okay. So if we plug 6 plus h into x, you're going to get a 6 minus 2 in there. Okay, so that's going to be 4. So it's going to be essentially h plus 4 in there. Minus. So f of 6 plus h means I take this chunk, I put it for an x. Yeah, 6 plus h in here. 6 minus 2 is 4. So I have an h plus 4 left. That's the formula in the red box. It's always going to be 0. Okay. Now we're going to do f of 6. That's a nice easy number for us, thankfully. 6 minus 2 is 4. Square root of 4 is 2. So that's what we have. Now, this is where you're going to get angry. Now what? Yes, conjugate. But I mean, you're going to get angry because now this story gets messy. That's why I have a second page in here. Okay, so we have to go h plus 4 plus 2. H plus 4 plus 2. Okay, so my top is going to be h plus 4 minus 4. Yes, we get the 4 to go away. Remember, don't FOIL the bottom until you see what the top is. So it's not that messy, okay? So it's like this. And so these go away. So they're gone. The h is canceled now. That's what we have on the bottom now. Now we can evaluate that limit. If you plug a 0 in here, 0 plus 4, square root of 4 is 2. 2 plus 2, 4. 1/4 is my slope of my tangent. Okay, I'll pause there. Any questions on anything I did there? Okay, so to finish it, we know 1/4 is our slope. The point was 6, 2. So we're going to go 2 equals 1/4 times 6 plus b. 2 equals 6 over 4, which is 3 over 2. 2 minus 3 halves is 4 halves minus 3 halves. So b is 1/2. So your equation of your line is that. 1/4 x plus 1/2. Okay, so you're going to notice something with this one, but this picture, it was x plus 2, right? Square root x plus 2. So that means this starts here, and it goes like this. Yeah, you'll be given them. It's fine. Okay. You'll be using so much so you probably won't need it. Plus a half, up 1 over 4. So this is for it to go 1/4 x plus 1/2. What was the graph again? Sorry. Oh, x minus 2? That's why. I was like, holy moly. Sorry, I drew x plus 2. X minus 2. My bad. 2, 3, 4. So it's like that. And then plus a half up 1 over 4. It's essentially going to hit it right there. That's what it looks like essentially. This right here is your radical graph. This is our line, our answer. Sorry, that's sloppy as all get out, but okay.